Hello friends, welcome back to our channel. So in today's session, we'll discuss about one more concept in operating system, that is readers writers problem in classic examples of process synchronization. So in our previous session, we have already seen one problem called dining philosopher's problem, and now in today's session, we'll see one more problem for in process synchronization, that is readers writers problem. So without delay, we'll start it. Readers, writers problem. So first we'll see what exactly the problem means, and then we'll see the solution. What is the solution using the semaphores? So here also we'll be going to use the semaphores for solving this readers writers problem. Yes, so all these are examples or problems of process synchronization. So when we are having that process synchronization problem, means when there are some limited resources. So for example, a database is having a file, and there are many processes accessing the same file. So for example, this is a process 1, this is a process 2, this is a process 3, this is a process 4 and process 5. So at a time 5 processes were exactly want to utilize the same database, a common or a shared database. And here accessing means there are two operations can be done by the process. One is a read operation, another one is a write operation. That means one process wants to read the file and one process wants to write, that means want to update that file. So for example, this process wants to read, and this wants to write, and this wants to read, this wants to write, and this wants to write. So then there, in such case, that means whenever a multiple processes wants to perform multiple operations, that means either read or write concurrently on the same shared file, then there is a problem of synchronization or inconsistency of data. For example, this process P1 was reading a file. For example, here let it be some x equal to 10. So P1 reading the file, so x is equal to 10. At the same time, P2 updates the file as x equal to 20. At the same time, P3 reads that x is equal to 30, because all are accessing the same file. So now you can observe the x value is different in P1 as well as P3. So that is called as an inconsistency. So here in the process synchronization, that means if multiple processes are sharing the common files, then how to avoid the conflicts or how to avoid the inconsistency, data inconsistency. So that we'll see. See, the things we have to remember here is the first one, multiple processes can read a file at a time. So if it is only reading the file, okay, if it is only reading the file, multiple processes can read the file. For example, see, if this is the process, two processes wants to read this file, then write operation should not be done here. Multiple reads can be available or multiple reads can be done, but write operation should not be performed. So if this is happening, P3, which is a write. If another process wants to write operate, then have to wait. Okay, if multiple, I mean the multiple read operations can be done, and write should be wait until it completes the read. So both read and write should not be done, right? So read at a time file, while one process reads a file, no other process should be allowed to write. So while one process or a multiple processes reads a file, no other process should be allowed to write. So write process, the process which wants to write this file, should be in a waiting state. Similarly, while one process writes the data, no other process should be allowed to read or write. So if one process is writing the data onto the file, no other process should be allowed either to read the data or to write the data. So if both are writing, if both the processes are updating the file, then also there will be a conflict. So here, see, if this is a database, and if one process P1 writes the data, then if P2 wants to read the data, have to wait. If P3 wants to write the data, have to wait. Okay, hope you understood this one, right? So operations can be performed. Operations can be performed is read, 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 and so on. Only reads can be done. Okay, and then see the second one, read operation followed by write operation should not be done. So this is happens. And similarly, write operation, if one process is writing the data, the read operation should not also be done. And the third, I mean fourth one is, if one process is writing the data, another process wants to write, then also this is not possible. So simply read and read is possible, read and write is not possible, write and read is not possible, write and write is also not possible. So these are the operations that can be performed on this readers writers problem. Okay, so in all these three cases, if it happens, then what happens? There will be inconsistency on data. Now such kind of things can be solved by using semaphores. We know that semaphores concept, it will be using two signals, that is wait and signal. So by using these two semaphores, okay, so we can solve the problem of readers writers, that if one process is reading, no other process will be with writing, and if one process is writing, no other process is allowed to read or write the file of the common data, I mean on the common data, right? So now let me write a small code which will give the solution for readers writers problem by using these wait and signal semaphores. Okay, See, by using this simple code for writing operation and reading operation, so we can have the solution of this readers writers problem. So here we are using the two binary semaphores one is called a mutex, which gives the status of mutual exclusion, which gives the status of critical section. Okay, so mutex, which will be initialized to 1, and another one is WRT, which is a write operation. Okay, write operation. So whether the process can be able to use the critical section to write the operation. So that is also initialized to 1. And one more thing is an normal integer variable, read underscore count, which is initialized to 0. So that will be used to count the number of processes that are in the, that are applying the reading operation, that are doing the reading operation. So because in our problem we have seen multiple processes can read the data simultaneously or concurrently, but no write operation should be performed and no read and write operation should be performed. For that purpose we are using this one, right? Yes. And this is a write operation. So we'll see the 4 cases. One is a read read, read write, write read, and write write. Okay, so first let us see that read and read operations. That means if two processes wants to read the data, for here mutex equal to 1, so we know that wait will be decrementing. So the wait means decrement by 1, and signal means increment by 1. Okay, increment by 1 as well as a decrement by 1. Now you can see the first operation is read. That means if multiple process wants to apply the read operation, so what happens? Reading operation, this is a code should be executed. So while true, this is a infinite loop. And here wait mutex, what's the value of mutex? Initially 1, write 1, and read count 0. Now wait mutex means, so the mutex value will be decremented, so it becomes 0. Initially it is 1, it is now 0. Now read count plus plus, so the read count will be initially 0, now it becomes 1. And if read count not equal to 0, that means here read count is 1, so the condition is true. Wait WRT, so wait WRT means the WRT semaphore will be become 0. Okay, WRT semaphore will be 0. And signal mutex, again we are using the mutex value, incrementing the mutex value 1, because we have said that multiple processes can apply the read operation. So if one process is reading, definitely if another process wants to apply the read, and it can be allowed into the critical section. So here see, now mutex is 0, that means mutex means which represents the critical section. Here the critical section is available, so reading operation is performed. So R1 is performing, that means process 1 is performing the read operation. Then again if another read operation is going to be done, wait of mutex, so wait of mutex, again a mutex will be 0. Now what is the mutex value? 1, so again the mutex value becomes 0. Read count plus plus, previously it is 1, so it becomes read count becomes 2, because plus plus. If read count not equal to 0, obviously read count not equal to 0 because it is 2. Then wait of WRT, so the wait of WRT means already it is 0, it will be in the waiting state, right? Signal mutex, so again increment the mutex value with 1, and now read operation. So here R2 is also doing the read operation. So you can observe in this case two read operations are being done. Two read operations are being done. Okay, if for example, if one process completes its reading operation, then see wait mutex. What's the mutex value? 1. So now the mutex value becomes 0. Read count minus minus. Read count minus minus means now the read count becomes 1. Previously it is 2, now it is 1. If read count is equal to 0, so it is false. So WRT should not be incremented by 1. Still the WRT value will be in 0 and it will be in waiting state. Because already one process completes its execution here. Okay. And there is still another process is applying the read operation. So if one process is in read, write should not be done. So until the read count is equal to 0, that means until all the read operations has completed their execution, then only the signal of WRT, then only the WRT semaphore will be incremented to 1 and it will be available for write operation. So here again, so this is false, directly signal mutex, again mutex will become 1. So why we are using this mutex multiple times means allowing the multiple users to read, multiple process to read. Okay, so this we can call it as a entry section, and this is a critical section. This is a critical section and this is the exit section. Okay, so this will be the entry section, that means entering the read process, and this is the exit section, leaving the process. So in this case you can see multiple reads can be performed on the thing. Now one read and one write, in this read operation. So the mutex will become 0 because initially it is 1 1 0. Read count, so let it be, take it as RC is equal to 1, initially it is 0. If read count not equal to 0, wait WRT. So WRT is decremented with a 0 and signal mutex, so mutex becomes 1. And now read operation, so read is going on. Okay, this is a process and read is going on. Then write operation, if go with this one, see weight of WRT, so here WRT is 0. So whenever it is 0, say it can't be decremented, the value cannot be decremented with a -1 because it is a binary semaphore. The value of WRT will be either 0 or 1. So weight means decrementing. See, weight means decrementing. It is already decremented by 1 because it is 0. So it doesn't allows the process to do the write operation here. So when if for example if it is the write operation is 1, then this can be applied. Okay, hope you understood. So wait and signal are, I mean this mutex, the WRT is a binary semaphore, it holds the value either 0 or 1. So wait means decrementing and signal means incrementing. So here already WRT value is 0. Now whenever a process wants to do the write operation, we are applying weight of WRT which will be decrementing. So already the value is 0, we can't decrement it, so have to wait. That implies the process is not able to apply the write operation and the process doesn't allow, I mean it doesn't allow the process to enter into the critical section. So write operation cannot be performed, so this is not possible. And for example, if you go with a write and read, for example write operation, first write operation, so the weight of WRT means WRT becomes 0. So write operation is going on, here, and then immediately we are applying for read operation, weight of mutex. So now the mutex value will be 0 and read count RC value becomes 1 and if our read count not equal to 0, here not equal to 0, weight of WRT, you can see weight of WRT means we have to decrement the WRT value, it's already 0, so it is not possible. So if it is not possible, the reading operation cannot be done. Okay, if this is not possible, this is not possible, because here the condition is true, read count not equal to 0, because read count value is 1, so the control should execute this wait process, but already WRT is equal to 0, that means wait is in, I mean write operation is going to be done, so none other process can't enter into the critical section, so the read operation cannot be performed. For example, the third next case, write and write. So if you apply the write operation, WRT becomes 0. So immediately write operation is going on. Write operation is going on, and until this write operation completes its execution, then only the signal operation, the signal will be executed. So write operation will be incremented, right? So here what happens? Whenever another write operation done, again the same code will be executed, weight of WRT, again the write should be decremented by 1, which cannot be possible, so write operation cannot be performed. Okay, so just remember these points so that this code will be very easy to understand. So here we are using a 2 semaphores, that is a binary semaphores. So mutex, which gives the status of critical section, so whether a process should be allowed or not allowed, and WRT is represents the write operation, whether the process can be allowed for write operation or not, and one integer variable for read count, because multiple processes can apply the read operation. So read count to know the number of processes that are in the critical section. Okay, so wait and signal semaphores, I mean wait and signal functions are the semaphore functions. Here wait means which will be decremented by 1, and signal means which will be incremented by 1, and here we are checking read read, write read, read write, and write write operations, where RR can be possible, where all other cases are not possible. So finally we can say that if one process is in critical section applying the read operation, so only a reading operation can be done by another processes. So if any process wants to do the write operation, it have to wait until the read operation completes its execution, right? So this is the readers writers problem, which can also be called as a classical problems of synchronization. These are the process synchronizations in order to maintain the consistency, okay, utilizing the shared resources or a common resources without going with the inconsistency, right? So here we also seen the solution by using the semaphores. So hope you understood this complete problem, and if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts, and if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.